I have the quadratic formula here right now, and I have the standard form of a quadratic. Your equation that you're working with needs to be in standard form. Let me highlight that over here. This needs to be in standard form before you can use the quadratic formula. So let me just real quick, first of all, talk about why we need the quadratic formula. And the reason is because we have seen equations like this that we can solve. And we've seen equations like this that we can solve. Right? And I can solve this by factoring into x plus 3 times x plus 4. And I set each of these factors equal to each other and solve. So x is negative 3 or x is negative 4. But what if I have something like this that can't be factored, or that I can't just take the square root of both sides? Well, this is where the quadratic formula comes in. And there is a proof of getting this formula that is in your textbook, and I'm sure that y'all have done this before in high school algebra. Complete the square and use that in a generic equation in order to come up with the formula. Okay, problem number 1. Here I have a quadratic that I'm going to solve by using the quadratic formula. First thing that you need to do is to be sure that your equation is in standard form, and it is. And I'm going to label my A, my B, and my C. And I'm going to write down my formula. I think the best way to learn a formula, to memorize it and to learn how to use it, is to write it down every time you use it. And there's also a lot of YouTube videos on singing this to the tune of Pop Goes the Weasel. So you can search for that if you want to. Negative B is going to be really the opposite of B, so the opposite of negative 3. And I'm going to write it like that just for this first problem. I'm probably just going to do a shortcut when I do most of these problems. Now, when you're looking at the b squared under this radical sign and your b is negative, you need to be sure that you put that negative 3 in parentheses, the squared outside the parentheses. 4 times 2 times 1. And all of that is divided by 2a, so 2 times 2. So x is opposite of negative 3 is positive 3, plus or minus. Now, the part that's under the radical sign, you're just going to stick all of that into the calculator all at once, and you get 1. I do not need that big of a square root. I'm going to erase some of that. From here, I can simplify by taking the square root of 1, which is just 1. And you can see that that square root has gone away. So I'm left with 2 rational answers. Remember, rational numbers are numbers that can be written as fractions, or the ratio of 2 integers. So I'm going to have 2 rational numbers here. Well, the first number is going to be 3 plus 1 divided by 4. And my second number is going to be 3 minus 1 divided by 4. Notice the only difference here is the plus and the minus. So this is 4 divided by 4, which is 1. And this is 2 divided by 4, which simplifies to 1/2. So those are my 2 answers. I'm running out of room, so I'll stick my answer up here. 1/2 and 1 are my answers. All right. First thing I need to do is to get this in standard form. So I need to get everything over to the left-hand side of the equation. And my A is 2, B is -8, and C is 5. So here's my quadratic formula. Square root of B squared minus 4AC all over 2A. All right, now here I have negative B, or the opposite of B. If B is -8, the opposite of that is +8. So that is going to end up with a -8 in parentheses here, and that is being squared, minus 4 times 2 times 5. And all of that is divided by 2 times 2. So x equals 8 plus or minus the square root. And just put all of that into the calculator, and you're going to get 24. And that's divided by 4. And again, I made my square root sign too long. Now from here, what I want to do is to simplify that radical. I'm going to take 24 and break it up into the square root of 4 times 6 here. And then the square root of 4 is 2. And then what I'm going to do is to simplify by dividing the 8, the 2, and the 4 by the greatest common factor, which is 2. So I have 4 plus or minus the square root of 6 divided by 2. Those are my two answers. I've got a square root here, so that's an irrational number. So my solutions are actually two irrational numbers. Problem number 3, I've got my equation given to me in standard form. I've got the quadratic formula written down, so I just need to put my A, B, and C into this formula, and I'm going to go ahead and put a 1 right here for my coefficient. So A is going to be 1. So negative B, or the opposite of B, so -3 plus or minus the square root of 3 squared minus 4 times 1 times 5. All of that is divided by 2a, which is 2 times 1. So when I put the stuff that's under the radical sign in the calculator, I end up with -11. Now when you put that in the calculator, don't put the square root in there, just put the 3 squared minus 4 times 1 times 5. Now you can see that I've got a negative under the square root, so I'm going to have imaginary answers. So I simplify this, and that's going to simplify into -3 plus or minus I times the square root of 11 divided by 2. Okay, with this problem, my first step is to get it in standard form. So I'm going to have 5x squared minus x minus 1 equals 0. I'm going to go ahead and put a 1 here. So the b is -1. So from here, I'd like you to try this on your own. So pause the video and then come back and check your answer. Okay, now there's a couple of ways to do this problem. One way is to think of this first term as having a coefficient of 1/4. This coefficient would be 1/3, and then you have your constants being 5/4, and then you would use those fractions in the quadratic formula. Now, I don't like to use fractions in my quadratic formula, so I'm going to do this problem a different way. I'm going to get rid of my fractions by multiplying through by my least common denominator. My least common denominator is 12. Now, you could have left this as 3 times 4 if you wanted to, but I think most students would think of the least common denominator as 12, so that's how I wrote it. So from here, I've got 12 times 1/4, so this is going to give me 3x squared. Over on the right-hand side, 12 divided by 3 is 4, so 4x. 12 divided by 4 is 3, so I have 3 times 5, or you could just put 12 times 5/4 in the calculator and get 15. Okay, so when I've multiplied through by my common denominator, my fractions went away. So now I have a regular old quadratic equation. I'm going to get everything to one side of the equal sign. Then I'm going to put this into my quadratic formula. And one thing I want to mention about the quadratic formula, it is on your reference sheet. A common mistake that I see students make is they think they have the quadratic formula memorized when they don't. So please look at your reference sheet when you're doing these problems. When you put this part of the formula into your calculator, don't type in the square root. Just type in the part that's under the radical sign, the -4 in parentheses squared, and be sure that -4 is in parentheses when you put it in your calculator. You'll get 196. And then you can try to take the square root of 196, and that is a perfect square. So you end up having 4 plus or minus 14 divided by 6. So you're going to have 2 rational solutions. Because my square roots went away, I can tell that I have 2 numbers that are just ratios of integers. Right, I have 4 plus 14 divided by 6 and 4 minus 14 divided by 6. So I have 3 for one of my solutions and -5/3 for my second solution. This problem is a little deceptive because it seems like because it's already factored, it's a little bit easier. But remember that when you're looking at quadratics and factoring, those factors need to be set equal to 0. So actually, this problem requires an extra step. We first of all need to multiply these 2 binomials using FOIL. Then we need to subtract 16 from both sides of the equation to get this set equal to 0. So I have x squared plus 8x. When you put this in the calculator, be careful. You're going to put this in as -48 minus 16. So that's -64, and then that's equal to 0. From there, I use the quadratic formula. Okay, so from here, I get -8 plus or minus square root of 320. Divided by 2. Now 320 is not a perfect square, so we have to find the biggest perfect square that goes into 320, and that's going to be 64. The square root of 64 is 8. So from here I'm looking at these 3 numbers to find the greatest common factor, and all of those numbers are divisible by 2, so divide everything by 2. And I get -4 plus or minus 4 times the square root of 5. My denominator would be 1, and I really don't need that 1 there, so I'm done. Now we've learned how to solve this type of equation by factoring out the greatest common factor of x, then set each factor equal to 0 and solve that way. But I do want you to know that you can use the quadratic formula on this problem, where a is 2, b is -5, and c is 0. So this would give me 5 plus or minus the square root of 25 all divided by 4. So that gives me 5 plus or minus 5 divided by 4. So my two answers would be 5 plus 5 divided by 4 and 5 minus 5 divided by 4. So this is 10 over 4, which is 5 halves, and this is 0. One other thing that I want to mention real quick about quadratic equations is that it really doesn't matter which side of the equal sign your 0 is on. In this problem, it would seem like it would be easier just to move the 4 over to the right hand side because most of your stuff is already over there. But because my x squared term has a leading coefficient that's negative, it's actually going to make the problem harder if I leave everything on the right hand side. I like my leading coefficient to be positive. I would move everything to the left hand side, so I would have positive 2x squared. And that's going to make your quadratic formula a little bit easier to simplify at the end.